Hi, my
Okay,
name is Minhua Liu. I'd like to welcome you to today's translation seminar of the Center for Translation. It is my great honor and personally a great pleasure to introduce today's speaker, Professor Robin Setton, who is joining us from southern France. Professor Setton is one of those interpreting studies scholars, who needs no introduction. He is known for his research on the pragmatics of cross-lingual communication, and specifically for introducing relevance theory as a research framework to the field of interpreting studies. His monograph, Simultaneous Interpretation, a Cognitive Pragmatic Analysis, which was published in 1999, and that is based on his PhD research, continues to be an important work with lasting influence in interpreting studies. And I'm sure many of you have also read another publication of his, very different in nature, but equally important, the 2-volume, very hefty Conference Interpreting, a complete course and trainer's guide, which he co-authored with Andrew Dorrant. And it is a book that is considered the most comprehensive guide to the training of conference interpreters. What you may not know about him is that he has a deep connection with this part of the world and also Hong Kong. He received his PhD in applied linguistics from the Chinese University of Hong Kong. And he was once the director of the Graduate Institute of Translation and Interpreting Studies of Furen University in Taiwan. And it was during this time when he and I had the pleasure of working with him as his colleague. He later taught at the Graduate Institute of Interpretation and Translation of Shanghai, Shanghai International Study University, Shanghai Gaofan. And he was a freelance and staff conference interpreter for almost 40 years, working for international organizations such as the OECD. And he worked with the languages, English, French, German, and Chinese. I may be biased, but I see Professor Setton as one of the field's most gifted practitioners, educators, and theorists. And he's also always one of the very few futurists in the field of interpreting studies. And I think he's in the perfect position to share his perspectives on what is happening in AI and interpreting. The topic of his talk is artificial communication, AI, and interpreting. Without further ado, I'm very happy to introduce Professor Robin Setton.
Good morning. Morning, everybody. Welcome to this, this talk. Shows the title Artificial Communication. Well, that'll become clear. I'll explain in a few moments. On the left, you can see the sort of joke subtitle, Homo faber meets Homo loquax, which means in Latin, man the toolmaker meets man the chatterbox. Two subspecies of humanity. So that's the idea. And so not a bad thing to leave the preview on the screen for a while. I'm going to, well, originally, the background to this talk is that about a year ago, I was asked by some friends in the relevance theory community, and I sent some readings on relevance theory to Esther and to the Translation Center. I don't know if the participants had a moment to look at them, but it's rather a complete and complicated theory. So I would try not to get too technical. There will be people who know more or less about it. So I was invited to give this talk and on something, and I could choose my own topic. So I chose AI and interpreting because there was quite a buzz about it. And there'd been a talk at Hong Kong Baptist U and other places. And 2 weeks after I chose this topic, literally the day after, 2 weeks later, ChatGPT hit the headlines. So this enormous AI buzz, which has been continuing ever since. So it's really a kind of peak AI spring. And it's very tempting to share all one's feelings and emotions about the AI buzz. We'll be looking at that briefly at the beginning. I want to look at that briefly because I think the way people react to this meeting between man the toolmaker and the people who want to, the tech community, people who want to make tools, and people who study talking and human communication, this encounter is quite fascinating, and there are emotions involved and fear and so on. So I want to look at that, and I put that in second position, but actually it'll be towards the beginning. I want to also give you the structure of the talk. I'll be asking some questions, questioning some assumptions, because the word intelligence, for example, has historical baggage, and there are certain terms which people take for granted and which affect the way we consider the question. But overall, what I'll be doing is fairly simple. I will be looking at this attempt, this ambition to either augment or replace human interpreters with algorithms, with speech-to-speech systems, machine interpreting. There are various terms, with automatic systems, partly or fully automated. And to do that, I will observe that the way the claims are being made and the way the products are being sold and promoted reflects a particular view of language, which is quite different from a more humanities view of language, but which is rather technical to explain. And so I am going to, instead of approaching and assessing AI's performance, especially machine translation, machine interpreting performance from a purely technical point of view, which I don't know enough about anyway, I'm going to, for a change, assess it from a rigorously, strictly human expectations point of view. So I'm going to take as my prism a theory of human communication, which is relevance theory, and which is the descendant of ordinary language philosophy in the 50s, Grice, and pragmatics. Anyway, we'll come back to that. So I'm going to look at basically the state of the art of history of machine translation, its current challenges. Then I'm going to take a few examples of performance, some sentences, and so on. And I'm going to discuss the theoretical potential and examine the claims, sometimes very, very inflated, of promoters and designers and marketers of translation systems. Then we'll look a little bit at human-machine collaboration, which is sometimes touted as a kind of intermediate step. Claudio Fancinoli spoke at the Translation Center a year ago, and I've been looking very closely at that, and we'll finish with a discussion. So, okay, I'm pressing this. For some reason, it's not going to the next. Oh, yeah, okay. So, some questions. These are going to be the questions I'll ask. Basically, can we, should we, and will we? What do I mean by can we? Well, everybody knows there's a tendency in our generation, especially with the leaps in technology, to do things because we can. You know, we have a lot of billionaires now. They also do things because they can, not necessarily because they should. So my first question is, can we? What's the potential? What would it take for an MI system to meet human expectations of interpreting? What are the prospects in the current paradigm? The second question will be, should we? Which is often forgotten, because really we don't have an authority, a world government or anything, or a general authority of humanity to decide whether a certain project should or should not be done. The atom bomb, for example, you know, it was up to the powers of the day to decide whether to develop it. But fundamentally, our experience is that once a technology starts, it's pretty impossible to stop it. But it's worth asking whether the project is worthwhile. Why would we want to replace human interpreters with automatic systems? What might be gained, and what cost? And finally, as I say, assuming that it will go ahead regardless, and we have a disconcerting tendency to see a lot of beta versions being thrown out because people are in a hurry, they want to sell things. So if MI is not yet mature, and of course I will show that it is not, but it is still deployed, what might be that impact of that on intercultural communication? So new AI Spring, there have been demos online of AI and of machine translation and speech-to-speech systems, and the emotions go all across the spectrum, from excitement. People say it's impressive, sophisticated, accessible, powerful, opportunity for multilingual communication, say even some professionals. Speech-to-speech translation, as it's called, is believed by many to be good enough for some applications or settings, and even by some who are marketing it, ready now or ready soon. But there's also been a lot of derision. It's always been easy to mock machine translations. Chinese menus are a very good example. Skepticism, you will see some example of AI skeptics. Fear now, we're seeing, you know, in the aftermath of a series of films over the past, I don't know, maybe 80, 100 years, science fiction showing robots, kind of modern day Frankenstein, Terminator, and a lot of talk in California and places about a singularity when artificial general intelligence will suddenly evolve human-like skills and want to take over. And in some cases, resignation, because, as I say, for most people, there's not much they can do to stop technology advances which may not be mature or may not be well thought out. Just to give you an example of the skepticism, of the derision part, we see, for example, AIs asked to show a picture of salmon jumping in a river. This is just a little comic interlude. As you can see, there's a slight problem with the algorithm's definition of the word salmon, which is taken in a kind of, supermarket context rather than a river context. But these are things that can certainly be overcome. It's a pity with Zoom, you can't hear gales of laughter, but I'm assuming that there is some amusement at this. Okay, now the great buzz of AI. Let's look at some of the reactions. People say they think it's good enough. These are people like Will Lewis from Microsoft. Some of these comments are taken from seminars organized by AIC, the Professional Interpreting Association, to discuss technology, which brought in some linguists and some developers. So a lot of them are saying it's good enough for straightforward applications or for routine applications. This is a theme which will come back. Other people say the Skype translator, for example, is demoed in 2016. It's better than nothing. As you look down this, you'll see a lot of kind of appreciations like reasonable output, not perfect. And towards the bottom here, it only needs some residual tweaks, otherwise called fine-tuning, like designing interfaces that can augment the translational hypotheses with context, for example. But we're going to look at it a bit more closely and be a bit more demanding. AIs can now tell jokes and make legal judgments, certainly, but is there a point to this if they're bad jokes, and what's the added value? So that's going to be one of our themes. Well, the first thing to hit the headlines really, really very spectacularly, as I said, in November 22, I think it was ChatGPT, and its reception bordered on adulation at the beginning, but within 3 months had already moved to doubt, and in some cases, anxiety or derision. This was by February 2023. What does it do, this ChatGPT? It does information lookup and possibly synthesizes and packages this information for delivery in pleasant language based on a kind of advanced mimicry. It's trained mostly on Wikipedia, and it is under pressure to perform. As we know, there's marketing in the background. It's been given features that are sort of crowd-pleasing. Okay, this is in French, but it's just an example of one of the ChatGPT tests that caused people to kind of change their mind about it. This was somebody who asked ChatGPT in France to give, they wanted to write something about one of the regions of France, in fact, one of the départements, the provinces of France, called the Lot, which is not far from where I'm speaking from. And it asked the ChatGPT to supply a quotation from various authors, like Rabelais, George Sand, Frédéric Mistral, and some well-known French authors. And the ChatGPT obliged with quotations which were in the style of these authors. And the user replied, "You made all these up. Not one is a real quotation." To which the ChatGPT replied, "I'm sorry, you're right. These quotations are not real. I based on the work of the authors to try and say things that would be linked to the Valley of the Lot, but I didn't check if they were really actually there. Sorry about the confusion." Right. So what we have here in the evaluation of ChatGPT, the thing that causes the buzz is that these generative AIs, there's a strong bias towards looking at the intelligibility. ChatGPT is very smooth, it's fluent, it's structured, it's completely derivative, of course, because it's based on a data set of past examples. And although it keeps saying I have no personality, it certainly does have a personality. It's diffident, apologetic, as you saw, rather servile, I would say, very well-meaning, politically correct, unless pushed a bit. And we have examples of where they managed to push it into making fairly racist and sexist remarks, but then it doesn't know, the poor thing. It's quite boring and repetitious. It's contradictory. It says it doesn't give advice, and then it gives advice. It says it has no personality, which it does. So at best, it's unreliable. At worst, mendacious, lying, fabricates, perhaps from a desire to please, which may be programmed into it. Now, some of us are familiar, anyone who's been on an interpreter training jury or even an admission jury is familiar with some candidates who are very plausible and very eloquent and very charming. And you have to listen to them very closely before you find out that some of them are actually not saying what the original speaker is saying. So this kind of bias towards intelligibility and away from the other big quality criterion of translation, fidelity, this bias towards intelligibility and plausibility is not promising for fidelity in translation applications, as you can imagine. Let's just look at some of what the skeptics have said about language AIs. The first one's too long to explain. Humans interpret information in contexts. We use context, but the contexts are not represented in the text, making it difficult for an algorithm to recognize them. The creator of the first chatbot, Eliza, 1966, which could almost pass the Turing test, remarkable 1966, but he himself said that he was worried about the computer revolution. We shouldn't use computers for anything that needs judgment or love or personal care or anything like that. That was Joseph Weizenbaum. We'll come back to him. More recently, Bender, Gebru et al. Tinit Gebru was one of the first critics of AIs to be summarily sacked from Google. And they have called large language models, which are the algorithms behind these AIs, stochastic parrots. They don't know, they don't understand language, they're just mimicking on the basis of probability. Another interesting quote by Yejin Choi, or Che, perhaps, a developer based in New York. She says it's really hard to see, and she herself develops AIs. She says it's really hard to see how they can ever get common sense. And she compares this. She conjures up an image where there's the surface of language, and an AI can only imitate and work from the surface of language. But in the actual process of communication, of which language, the surface string of language is only a part, is only a skin, there is a large background necessary to communication, which is shared, unspoken, implicit knowledge that we all have as humans, and that which is needed for understanding exceptions, for example. I'll go back to that salmon jumping in the river, or needed for humor. And this is such a large and important element in real communication that it's like dark matter and energy is in the universe. Probably 95% of the total is needed to explain ordinary matter, as common sense is perhaps 95% is of common sense, of communication is common sense, although it's invisible. So we're going to look at the description of the two systems. This is how we're going to proceed. I'm going to try to outline how these rival systems work, the human and the machine, as far as we know, because we're living in a world where there's corporate proprietary secrecy. So a lot of stuff is not open source. So we don't know as much as we could, especially if we're not experts. So we're going to look at the state of the art of MI, how it works, and then theories of human communication, how that works. Which is not transparent either. We only have theories about it and how translation works, relevancy in particular. Then we're going to compare performances as far as we can, looking at samples. Then we're going to look at, we're going to get serious with our evaluation, see what real life interpreting requires and what is expected of it, and measure MI or potential MI against that. And then finally, we'll look at the other two, should we and will we. So first, just a few words about, some of these terms. I've called this artificial communication because that's what it's trying to do, machine interpreting. Artificial intelligence has to be understood against the whole project of artificial intelligence, and the way it's looked at and its performance has to be looked against the historical background of a bias in our definitions of intelligence to the manipulation of information, to the storage of information, especially facts. And so therefore the importance of memory and storage. For a long time, people who had huge memories were automatically considered to be the most intelligent. So there's a quantitative bias towards intelligence, a bias towards smart calculation, computation, and problem solving. Recently, novelties have been introduced like emotional quotient instead of intelligence quotient, but they haven't really filtered into our, if you like, folk understanding of the term intelligence, which is still biased towards that kind of memory, fact, fast computation intelligence. Language, there's also a folk view of language. If you tell people language is a tool for exchanging information, a lot of people will say yes, 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 you know. But actually no, because that's just one part, and often that could be communicated, pure information could be communicated in various other formats. Real life language and speech is usually persuasion, using information for its purposes, for its persuasive purposes. So if you tell people language is a code, they will also just unthinkingly often say yes. Translation is also, unfortunately, by many people, because they know no languages, or they basically come up against language differences as an obstacle, for example, on the internet. If you tell them translation is a tedious, code-based problem-solving task, in other words, different languages are mainly a barrier, a lot of people will go along with this. So again, if you accept this language is basically a code, it's a tool for exchanging information, and translation is a tedious job, and language is a barrier, then fine, then we should leave it to machine interpreting and translation, because they're better on purely factual stuff. So what is interesting is that what we see now in the project, in the AI project, is the emergence of two different cultures in linguistics. Basically, the partners towards the middle of the last century, behaviorism gave way to cognitive science, an interdiscipline, and the partners in theory who came together in this cognitive science were anthropology, computer science, linguistics, philosophy, and psychology. And surprisingly, you might think, for anthropology and psychology, basically they accepted in this new partnership to agree that the mind is computational in a very wide sense. I mean, you had some structuralists in anthropology and perhaps even in psychology. Anyway, it wasn't too much of a stretch to accept that in theory. But in linguistics, there really was a split. Some linguists became computational linguists, and sticking to a code model of language, whereby language can be completely and fully described by rules, phonology, grammar, and semantics. Whereas another group was more interested in what was being studied in the early 50s and 60s by people like Grice, ordinary dialogues, and to try and understand what the difference was between what we see on the page and what we understand the person talking to us to actually mean. And from that to start looking into the explicit meaning and what it takes to actually reconstruct that, and then the implicit meanings. And it turns out that this led on to relevance theory, which basically shows that there is these multiple layers underneath of meaning, which we put together by context, by bringing in other contexts and considering and analyzing the sentence we hear in a context. Not only that, but that in language, there are parts of language, there are words and pieces of the language that encode facts and qualities like adjectives and objects, for example, and concepts like nouns and so on, that encode conceptual content. But there are all kinds of other bits of language that nobody could really define, like and the, and of course, and yet, and in every language there are lots of these little things, different ways of saying the same sentence, like an expert, I am not, instead of I am not an expert, and all kinds of other funny little, what Goffman used to call greasy parts of language, which now turned out, as relevance theorists have been finding out and elaborating over the years, to be usefully seen as actually not encoding concepts, but as being sort of pointers, instructions, which help you to make an inference, to see how the speaker wants to take the information. So these things are not always explicitly represented and perhaps hard to use. So as you can see, this is these are two completely different cultures, and it's reminiscent of the very important speech made in 1959 by C.P. Snow, a British intellectual who observed that there was an enormous gulf between the arts and the sciences, which was damaging to progress, you know. So this is something a little similar. I don't know what sort of how the time's going, but okay. So we have two conflicting models of language and communication. This is a little bit repetitious. The code tech world also sees language, tends to see language as a grammatically correct standard, as you might find in a grammar book. And what deviates from that is considered often as noise or disfluency. Whereas, as we'll see, it might actually be information about guidance to inference. Also, it's interesting when you say that when you consider these models that look a bit behaviorist, you know, based on stimulus response, is to notice that these models are indeed trained on a reward model. You know, when they get it right, they get rewarded and so on. One example was a quote of this mentality was a thing said to a journalist who went to an MI conference from a literary magazine. Somebody said, look, Don Quixote, the Spanish classic, has been translated 11 times. Well, those translations can't all be right. So the idea that there's just one correct translation. Another noticeable feature is, with this code model, is the slowness to understand the differences between written text and spoken language. After all, it's all in the same code and the same words. And the data sets on which these algorithms are trained are almost always text. So they were way behind on recognizing features of orality. And the solutions to the problems faced, as you will see, are always proposing new add-ons, which are always rules, new rules, or removing things, cleansing. In other words, there's a blindness and a resistance to a pragmatic account, but that'll become clearer. Okay, this is just an example of MI experts at some of these events talking to interpreters. The fact that they would say these things to interpreters shows that they have no idea what people who are on the front line who actually work with language, like interpreters, understand about language, because they themselves don't really understand it. So they think they're discovering these things when they say that people are disfluent and people, what they think they say is not really what they say. People don't talk the way they write. Oh, you don't say. People don't talk with punctuation. How to filter out this fluff that's not relevant? How can the machine understand the pragmatics as if it's going to be a simple thing? Ideas for improvements show also a certain naivete. Just residual tweaks are necessary, fine-tuning. We just need an interface that can add contextual information. Or they make distinctions between so-called routine translation and non-routine. Well, we'll come back to that later. And so on. These are things that will come back, so we mustn't spend too much time. This is a summary of some of the different conceptions of interpreting. We, and I forgot to say, Minhua explained I was an interpreter, so not a robot. We humans often see interpreting as intercultural communication, but designers of MI often see it as something which will help remove the language barrier. They see language as a more complex code, and the importance is biased towards information and correctness, and also fluency and convenience, and perhaps also flattery and politeness, as we saw with ChatGPT. These are marketable values, as we will see, rather than ethical values like authenticity and validity, but there I'm jumping the gun a little bit. We probably are more aware that people who talk to each other are sharing not just facts and information, but stories, experiences, pictures, convictions, and emotions. And the rest will become clearer later. So let's look at these two systems. We're going to try and understand how MI works, how the human mind works in doing this task. What is a task? To produce speech in a target language that faithfully and intelligibly, and here we have what I consider the inseparable dyad or the inseparable pair of quality criteria that all quality research comes down to. Basically, from translation, people want it to be faithful and they want it to be intelligible. And not just intelligible for a sentence, but comfortably intelligible, if possible, idiomatic, and so on and so on. But that's the base. Neither is enough by itself. There's no point being faithful if you can't understand it. There's no point being understandable if it's not what the speaker said. And in relevance terms, the aim can be described as aiming for a translation that gives the speakers access to the same range of cognitive effects. It's a relevance term for meaning. It gives them the same richness of meaning for the same effort. That's the intelligibility side. In other words, without having to strain to understand. The same effort to effects ratio that is available to listeners in the original language. So how do these two systems do this? Well, the human brain, as we know, has evolved. Latest theory says it's probably modular, massively so, with different modules interacting. The machine is often described as presented as in stark contrast because not evolved, but designed. But now there's a twist to that because the neural deep learning current paradigm of machine translating algorithms, of AIs, in fact, is very complex. It's basically an outcrop of connectionism with all kinds of improvements like backward propagation, feed forward, diffusion, and so on, which I wouldn't go into even if I knew about it. But it is so complex now that it is fairly opaque to its own designers, and it's claimed that it can evolve by itself. Well, it can, in a sense, learn by itself. So this evolved designed opposition is not quite so clear-cut. The human brain, which is a black box also, more so perhaps, has language and it's embodied cognition. It's a mind that's in a body, which perhaps restrains and perhaps also nourishes it. And it uses various things like perception, memory, and also inference and meta-representation, being able to project other people's context, sometimes called mind reading. Now, I list those because a machine could also, a robot with an AI could also have perception. It could also have, it certainly has memory, and much faster than ours. It has a kind of inference, and I guess it has a kind of representation. It can represent things, although that's moot, but there aren't all that many, we have to concede, the reasons why these things could not be connected up in a certain way. But we must continue to see, for the moment, the algorithm does what it says on the right. It learns to process and produce language based on what patterns that it extracts from a vast corpus, billions of pages of data, and pairings between languages. So based on this, statistically, it has an infinite number of environments, and it finds the best fit and strings it together with remarkable results. The first spring of AI and machine translation was in the 50s. It was easy right from the start to do factual things like weather forecasts and mathematical proofs. The first systems were all based on rules, the so-called symbolic computational flowcharts that you were familiar with, especially from my generation. Yes or no, logical gates, and so on. The input has to be controlled. And in some cases, they would use a meta language, saying that everything has to be passed and then repassed. Every step is specified and it's transparent. Well, this had limits, couldn't do all that much. But in the 80s, there was an enormous leap in power of computers. In Japan, in particular, chips and so on, and they actually developed systems which they managed to market a bit for tourist applications. And the first example-based statistical MTs came out. And then there was a bigger leap still in the 90s, where the seeds really of the current paradigm were sown. The neural networks, machine learning techniques that led to machines beating humans at chess and Go. That was what was called deep learning. And today we have neural machine translation and generative AIs like ChatGPT, which, as I say, nobody can say exactly how they work, and some of them are quite worried about them, especially about what they might develop. You have the idea of a singularity where they take over, which I mentioned earlier. That doesn't apply quite to speech-to-speech translation algorithms, and perhaps the dangers aren't so great. But we do get these promises on the positive side of emergent capabilities, that somehow these machines now can learn by themselves, and somehow there will be emergent human-like skills that will come out. So I have to try and stick to machine interpreting and not AI. The state of the art for automatic translation now is still based on a cascade model. There are 3 modules: automatic speech recognition, recognize the speech, and then sent to the translation module, and that produces typically text translation, which is sent to another box that turns the text into speech. There is one in particular. Google tried to develop something that skips this or goes directly or pairs, since they work on pairings found in a data set. They take spoken pairs and they're trying to develop an end-to-end system, but you can't test it. They just give you a few examples translated from Google. Okay, here are the current challenges, the problems being faced by machine translation in the different modules as recognized by the developers. This is a compilation of recognized problems that they see. Now, for recognizing speech, there are quite a lot, of course. External noise, I'll let you look at those. There's dialect, bad diction, people are wearing a mask, punctuation, difference between let's eat and let's eat grandpa and let's eat grandpa. We'll come back to that later. Oral ambiguities, different styles of speaking. Of course, there are lots of non-native speakers, which leads to the idea of re-speaking them. We'll come to that later too. And loose choices of phrase. But in some cases, they may be loose choices, but not loose choices, but deliberate choices of unusual phrasing, like creative metaphor. And we'll see how that really does cause a problem. In extreme cases, poetry, of course, but it doesn't starts well ahead of poetry. Then there are acronyms, people who say, they've got DPPV and ARN, you don't know what it is. And these things can be trained in. They're often specific to a company, but they're not recognized automatically. Same thing as so-called disfluencies, people who repeat themselves or stammer or put in and but it's hard for the machine to tell which of these are meaningful and not. And then, of course, when people talk at the same time and so on. So all these challenges, there's quite a few challenges, just for the speech recognition. The next module is the machine translation module proper. And here we're going to be seeing more of this. Lexical ambiguity, for example, changing a tire. We'll see that was an example in a police guide. What to do: go behind the car and change a tire. Well, they mean change uniform. Lexical ambiguity. Then there's sentence ambiguities. I won't be the last person to, the first American president to lose a war, Reagan said about Vietnam. That's an ambiguous sentence. And then there's marked word order. What's the difference between saying I'm not an expert and an expert I am not? For example, named entities. We'll see that Hull, Cambridge are towns, but they can also refer to universities. Southern California, is that an institutional name or is it an area, and so on. And again, we have culture-specific things, idioms, which are going to be very important, but can be solved. Then there are problems of different rhythm. There are new words. They have a lot of trouble keeping up to date with very recent words. I have trouble myself. Then again, corporate specific and custom terms that are misused, human error. Of course, sarcasm, puns. The problem is when we use a different word from a different language. The question of latency, which, for example, the Baidu system, simultaneous system, is real concerned with and tries to imitate UN interpreters. And of course, some more serious social things, which the machine inherits from its data set, like gender biases and race biases. So these are all challenges in the MT module. Again, not a few. The final module is text-to-speech, and I would say that it's probably the poor relation. It's far behind compared to the others. We hardly see it mentioned. It's not very developed. Basically, I tried I clicked on the loudspeaker for DeepL translation, so it would speak it out to me. And it was very pleasant and melodious voice, but meaningless. So that's still, it seems to me, rather in its infancy, the connection between the meaning and the prosody to actually imitate human prosody. Of course, if you can't do that, it's going to be pretty unintelligible, or if it's barely intelligible, very tiring. Now, let's look at the challenges of the whole combo together, the whole cascade. Well, what you find if you do the research is it says that apparently what a major mistake, a problem of whole cascade systems is error propagation, in the sense that once they misread something, they can't look back. For example, if in German Reben, which means vines, is recognized instead of reden, which means speeches or talking, then it'll mess up all the next stages. Okay, that's why Translatotron probably is trying to collapse the cascade and do end-to-end speech pair to speech pair. Okay, I just try and keep an eye on the time. Oh, it's getting on. Okay, so this is just an example of why, some examples of why we look at performance and we have a positive bias. We give a pragmatic benefit of the doubt. What does that mean? Well, firstly, because we're actually wired by evolution to try and make sense, do our best to make sense of anything we hear. This is a relevance theory comprehension procedure. If somebody says something and the words don't quite fit what you know, well, you loosen them, you adjust them, you say he must mean this. All this happens very quickly. You make a big effort. You're tolerant. You make a big effort to get some meaning out of it. So people tend to. Then secondly, there's people are fond of technology, so they have a pro-technology bias, and so they want to find meaning. Then there are a lot of, in translation, there are a lot of things that are ambiguous, and they're translated word for word, and they're still ambiguous. But it doesn't matter, because you think, oh, maybe the speaker wanted to be ambiguous. But after a while, it gets a bit wearing, because a normal interpreter would actually try to clarify some of these things by using their voice, or trying to notice whether the ambiguity is intentional or not. It's not always intentional. If everything's vague and ambiguous, it gets too tiring, too much effort, not enough effects. We only see these problems. A lot of these things go through and are acceptable accidentally. For example, of course, and anyway, these are pragmatic. After all, these are pragmatic, but often they have direct equivalence in these languages, so they go straight through, but they may be misused. And it comes out on things like creative metaphors. My son is a baby. Most interpreters in many contexts would probably, to make it clear, say in another language, mon fils n'est qu'un bébé. My son is nothing but a baby, something like that. We'll see with more examples. So fast, fluent MT will enjoy a positive intelligibility bias, but it's vulnerable. So current systems may seem good enough, but we must judge performance from both ends. Machine interpretation by its own standards, which we've been looking at now, and by human user expectations. So can we try and trap it? Well, these are some of the things that I tried to devise or select examples to test. Idioms, ambiguities. Unfortunately, text-to-speech could not really be tested as far as I can see. There's Baidu has got a so-called end-to-end system advertised from 2018 called STACL Stackle, but by 2019 it was hard to get hold of it, and we weren't really able to easily access it. So I wasn't able to find a complete end-to-end system to demonstrate. Some of the systems you can demonstrate for yourself online are Microsoft Azure, Seamless M4T, from Meta, DeepL, which gives you text in and out. Azure, you can put in oral input. Actually, I believe DeepL, probably you can get oral input and output as well. And ChatGPT, and some of those have translation capabilities. You have things like Bard have come out more recently, and so on. Okay, so we devised some short dialogues and so on. When it's voice input, I tried to read it in very clearly, standard UK dialect without any noise, to focus on the translation performance. Here are some examples. The first one was a colloquial business meeting speech. It's rather heavy on idioms, I think you will probably notice, but very quickly, this is how it sounds. It's like a guy, with his sleeves rolled up, and he's brought his colleagues over for a quick meeting on a Saturday. All right, everyone sorted and comfortable? Most of us are family, but there are a few visiting firemen, so perhaps we should go around the room just to break the ice before getting down to brass tacks. I know it's late. I'm sure we'll get a chance to catch up later, but for now, we need to make sure we're all on the same page before we get into the nitty-gritty. I'm not here because I had nothing better to do on a Saturday afternoon. So, okay, as I told our friends at First Provincial, we're not applying for this loan because we have doubts about the viability of the project, obviously. The numbers are in, accounts have been quite clear, they see no particular clouds on the horizon. But make no mistake, obviously there's a lot to be taken care of. We're not sitting on our hands. So let's get stuck in. Okay, that was all the bit that I really used in the examples. Now, I've had to choose a few languages, not knowing who was going to be listening in. But basically, that didn't do very well. DeepL didn't do very well on idioms. Microsoft Azure, rather. In fact, none of them did very well. DeepL was slightly better than the others, but they did quite poorly on idioms. For example, sorted is a fairly recent sort of British way of saying everyone's fine, everyone's okay. Well, French translated it as trier, which means, triage, like you sort things into black and white beads, for example. So that's quite wrong. Most of us are family. It tells us, French says have family, because it probably doesn't know our family. German translated as our family, although I'm not sure it's used in German. Visiting firemen was not recognized at all. They both literally say there are a few firemen who are here visiting us. And going around the room sounds like walking around the room. And as for getting down to brass tacks, well, they talk about brass blows or brass needles, or basically zap that one completely. Then the other interesting question was these negative sentences. I'm not here because I've got nothing else to do on a Saturday afternoon. I'm not here. We're not making this loan because, well, that should have been on another page, because that's not an idiom. But another example of idioms would be something like war is a dirty business, which, as you can see, is translated in Chinese. The first attempt, business, is translated as commerce, and partly corrected. So there's a problem here, actually, of two kinds. Idioms are not recognized, but that could be easily solved with a data set. I don't see that as a big obstacle. We just have to increase the data set, use wider examples of different kinds of books and speeches and so on, which have to cover all the idioms. And that there's a lot you can do by still widening the data set. War is a dirty business is a little more complicated, because you have to adjust the meaning of business and dirty to see how it applies to war. But that's a question of loosening and concept adjustment, which is a pragmatic thing. And again, that shouldn't really be on the same page as idioms. Okay, this scope ambiguity. I'm not here because I have nothing else to do on Saturday afternoon. Now, these go through in French, Italian, and German, but a little bit doubtful. The thing is, they're not actually wrong, because they're just word for word. I am not here because I had nothing to do on Saturday afternoon. So these would be examples where the ambiguity goes through, but it so happens that in those languages, that particular type of sarcasm or irony is not really used in the same way. So it's a little weird. You can't actually say it's semantically wrong. Whereas in Chinese, because of the different logical structure of the language, the translation module is forced to decide. And in fact, it is correct. And in fact, you can see that it's been forced to decide between two logical scopes of the negation. So it ends up saying, I am here. If I am here, implied, it's not because I have nothing better to do on a Saturday afternoon. So that's interesting. Then we're not asking for this loan because we have doubts about the viability of the project. Same as before, it's still ambiguous, but that's a little bit tedious when that doesn't really convey irony in French. Same thing in German, except that in German, in one case, we put in the word obviously, and the translation machine put the word obviously in a place which made it wrong, because we stuck it at the end, as you often do when you're talking naturally. We're not applying for this loan because we have doubts about the viability of the project, obviously. But maybe in the samples for the data set, in good German, it thought you should put an obviously somewhere in the sentence. It got it wrong. It said, not in this case, but in another case, because we obviously have doubts. We're not applying for the project because we obviously have doubts. Well, that's wrong. So the fact of putting in these little things like obviously and evidently and frankly in the right and the wrong place is something that the algorithms have not yet mastered, and it's pragmatic, so it's hard to see how they would. Now, another thing that we do is that we may use, if we're given context, we can disambiguate. For example, the word toujours in French can mean still or always. This says mon potager est toujours plus petit que celui du voisin. My kitchen garden is still or always smaller than the neighbor's. No, my kitchen garden is always smaller than the neighbor's. That's weird. So apparently it can't disambiguate using its concept of the word kitchen garden. Maybe it doesn't have one. And then, do you always take the same train to go to work? Or do you still take the same train to go to work? With no context, DeepL gives the two options, fair enough. But with context, explicit context, I saw Jacques the other day, I haven't seen him for 20 years. I asked him s'il prenait toujours, if he still, normally we would all think if after 20 years, he would ask if he'd still take the same train, but no, DeepL says always. So there's some problem in using even explicit context. Now, can machine interpreting recognize intonation, which for us immediately disambiguates things? Here's some examples. I don't love you because we grew up together. Implicit, I love you, but for another reason. Well, some people may not be sensitive to that. They may be British. But I don't love you just because you were the boy next door. Was delivered flat. I don't love you just because you were the boy next door. And then it was delivered with, I don't love you just because you were the boy next door, you know. But that made no difference most of the time. In other words, I won't go into detail because I don't have time, but the systems were not sensitive to these major differences, sometimes opposite meanings due to intonation. In Chinese, here, for example, you see it gets it quite wrong. It's obliged to choose. It can't be ambiguous. It says, I don't love you. So, and then it says, that's only because you're the boy next door. Right. Here's some other funny examples, the 7-foot doctors examples. The hospital was sued by 7-foot doctors. Well, you can imagine somebody who's non-native would not pronounce that well. This is a well-known joke headline, actually. The hospital was sued by 7-foot doctors. Well, I can give you a couple of seconds to see how the machine tried different solutions. Sometimes it produced nonsense. In Chinese, it was a 7-foot tall doctor. It sounds like a 7-foot tall doctor. I did a back translation for fun of the translations, which produces strange results. Like in Chinese, it said Dr. 7 feet when I put it in DeepL for a back translation. So, and then sometimes so French and Chinese are both understandable, but not idiomatic. Sometimes it's nonsense. And in Italian, foot was omitted, not quite sure why, maybe it's getting cautious. Here's some examples of name recognition. And when a place is being mentioned, or a proper name is used metonymously, metonymy, right? If sadly Mary hasn't got into Cambridge, she have to go to Hull. These are two universities. That failed. And in Chinese, it failed in 3 ways. Although the Chinese recognized Cambridge as a university, not admitted to by, that's my mistake. She's not admitted by Cambridge. They got that right into the Chinese, but they put sadly in the wrong place. Because originally, well, it's not too different, but if sadly Mary hasn't got into Cambridge, and then finally there's a plain recognition thing. The algorithm doesn't know Hull, so it puts Helsinki in, which is a little bit wild. Okay, another example from that little business talk. Accounts have been quite clear. Well, here accounts is used for the accounting department, obviously. The French didn't pick that up. It says the accounts were very clear. And Chinese selects accountants, which makes more sense. And you can do that with a rule. So on a rule-based system, you just have to have a rule that says you can't put together an animate subject, or at least you need an animate subject for the verb see. So you can explain why some would get that right. But obviously, this is also a problem. So very quickly then, all the first thing, credit where credit is due, all these systems are much faster than humans, and they are generally complete. I have done other tests and so on, although there are unexplained random omissions sometimes, even with these systems. From ChatGPT, I put in a dialogue and some couple of lines were just left out. It's strange. So that's like humans. Idioms, very poor. DeepL was slightly better than Microsoft Azure, but lexical ambiguity was a little uneven. Proper names were poor and slightly better with DeepL. So those are the things broadly that could conceivably be cleared up by a more up-to-date, larger data set and faster computing. In other words, same carpet bombing, brute force approach. Whereas the others, sentence ambiguity, this thing about not and the logical scope and the expression of irony and the sensitivity to context or to intonation, for disambiguating, those two, it's very hard to see how the current design could resolve those one day. So again, poor on idioms and proper names could extend the training set. Metonymy and metaphor require loosening, which are pragmatic things. Conceptual adjustment, which doesn't do. Mark syntax, same thing. The irony, as I say, I've just said that. So the voice output, finally, you get clear diction, but because one of the outputs from DeepL, I clicked on the loudspeaker just to see what it sounded like, because they offered me a readout. And basically it was one of those kind of Muzak type flight attendant voices, but with even less meaning. It was a pleasant voice with a kind of artificial prosody, and it was incomprehensible because it didn't fit the meaning. So that's why I say the text-to-speech component seems to be far behind. Okay, so this is actually something I already said about the positive biases, so I won't go over that again. We often accept a text if it's superficially intelligible. Things that are actually English that come through, which are idiomatic in English, we might accept too, simply because English is so unavoidable now, so we're sort of more tolerant of the lingua franca. So at the bottom here, the result of all this tolerance is that we may make sense of each sentence one by one. Never mind if it's not idiomatic, then we say, oh, never mind if it's not very meaningful, it could be ambiguous. But in the end, we have less and less cognitive effects and more cognitive effort in relevance terms, until you don't have a threshold of it's not worthwhile anymore, listening. Okay, so this is what I call the pragmatics bonus that the machine enjoys, because some words like after all and of course have the same value and they go straight through. The same with ambiguous elements that go through as a sort of pragmatics bonus. But in real life, the interpreter will try to relieve this, will be aware that this is becoming vague and fuzzy, and will use a thing which we call in our textbook that Professor Liu mentioned, optimization. This is a kind of second level of pragmatic processing that interpreters must do. And sometimes the actual surface word is translated, and it might be ambiguous if it was translated, but being aware it's ambiguous, people who are speaking put in other things like intonation to disambiguate. And the machine is not sensitive to that. So we have a deficit there, which makes up for the bonus, so to speak. In real life, interpreters compensate these losses. So here it's a little bit theoretical. Basically, interpreting goes well beyond linguistic decoding. It's a multi-level process. Translation, because words, languages don't fit together one-to-one, and because basically the speaker's performance is a holistic thing where she can use body language, intonation, and all this together as a kind of art form. And that's broken up because it's now my voice. So I have to speak. So there's a kind of loss. There's this kind of general entropy or loss of information, which goes all through translation automatically and inevitably. And I have to compensate that. Speakers are hearing me and simultaneously through a headset, they can't see anything. I have to speak more clearly than usual and avoid vagueness. Now, to do that, I use my linguistic competence in speaking clearly, properly, good grammar, and so on. But that's only level one. Interpreter must also filter loose talk, noise, speaker errors, disfluencies, and compensate for them somehow. Next, I'm not sure if there are 4 levels, there might be 3, but she must recreate the communicative clues and pointers that direct listeners to inference. Things like sentence marking, after all. I think by now you see what I'm talking about. And finally, interpreters must always optimize the relevance. If there are final adjustments to be made, for example, because the concepts, the contexts that are available to the target audience may not be the same as the ones the speaker assumes to be obvious to her direct audience because they're from a different culture. So in interpreting, you have cultural bridging. It may be social bridging. They may be from a very different class. You're talking to a policeman, talking to an impoverished boat person, a refugee, or someone who is uneducated, requiring benefits, talking to some official and so on. So cultural class, cultural differences. And then, so, which the interpreter has to understand and see this gradient of power and optimize. There may also be different preferences in different settings, different situations, like in diplomacy, you have to be extra tactful. In court, you have to be very precise, sometimes word for word. On the media, you have to, sometimes they don't care so much about exactly what the person says, as long as it's cheerful, upbeat, and entertaining. All these things are part of optimization, which is really quite another level needed for interpreting. This is, for example, 7-foot doctors. 7-foot doctors would be discounted, even if it sounded like 7-foot tall doctors in optimization. Sorry. Sorry, wait a minute. Have I gone? No. Okay, so we have to now we have to get down to brass tack. We have to decide that we're not going to be impressed by MI performance compared to what it used to be able to do. We've got to look at what is expected in real life, and it's not just fidelity; it's sustained, comfortable intelligibility. It's not just intelligible. Sentence by sentence. It has to be comfortable over a whole event. So we've already seen that if you casually test an MI with sentences, you won't see the problems because people make adjustments, the language, the translation goes through. Okay, so I think we've dealt with that. Optimization is necessary to reduce effort and increase relevance. And this is the full definition of optimization, as we call it in the textbook. It's amazing when you look at what interpreters actually do, what the violence they have to do often to the basic coded language, the things we have to do. Even the form has to be, we have to shape the form. We have to try and improve signaling and saying, first, second, and third. And now I would like to go on to say, we have to adjust register, cheer up our voice, use gestures and consecutive. That's all form. Then we have to also change the content. Yes, we have to annotate and explain sometimes to bridge culturally, make something explicit, more explicit. Sometimes there's an obvious speaker error. You won't thank us for repeating it. A mispronunciation, a number that don't match the slide talking to you. You can see it's an error. Sometimes we have to omit. Sometimes we have to be concise because it's too fast. Even if we could do it that fast, which the machine certainly can, the audience wouldn't be able to take it in. So sometimes there's a reference to some institution, for example, some ministry or association in India, which I may not have heard of if I'm from France or the USA. So I could say the Indian Tax Authority, for example, instead of the name. And then there's process. Sometimes we have to ask the speaker to clarify or to slow down or something, which I guess you could get technology to do. or you clarify your own role as an interpreter. So this is quite a lot of operations in real interpreting in real life that it seems difficult to see a machine taking over. Okay, I just thought I'd go away from interpreting for a moment and show how actually, even in subtitling, there are multiple parameters that often have to be taken into account all at the same time, especially from in a documentary from Chinese dialects into English, which jump around between different scenes. You have to take into account the length, the speed of the subtitle on screen, and the information in the subtitle against what the information, what can be visible on screen, and also what the audience knows. The audience being English speakers and who know a hell of a lot less about the background than the Chinese speakers who are watching the Chinese documentary. So multiple parameters, all to be juggled. So that's another example where I have difficulty seeing an algorithm taking over. So this was the 3 levels of pragmatic processing beyond decoding, which I already dealt with. I'd like to just say, basically come back to this, the theoretical judgment now. We've got to make a judgment about whether, because we're faced with automatic translation systems, so-called, that are being presented to us as ready or nearly ready, or we're being told that if they're not ready now, they're not perfect now, they soon will be, because either it will learn by itself or learn human skills, sort of hand-waving approach, or we just add a few tweaks and fine-tuning, as it's called. So before we get there, to really answer the question and make this judgment, let's really look at our methodology and on what theoretical basis we're going to make this judgment, because these claims are very strong and there are a lot of people who find it difficult to doubt these promises. So what is our basis? We take a square of 4 things and we look at them. What do people want from interpreting? And here we have to be ruthless and see exactly what people really want, and not, accept these benefits of the doubt. We look at how we communicate, relevance theory, how we think we communicate. We look at how translation AIs work, what they can do. I don't say communicate because I don't really think they can actually communicate. That's why I say artificial communication. And we've analyzed the problems that AIs actually have in their own terms. So we've looked at those things. What do people want for interpreting? Fidelity and sustained intelligibility. How do we communicate? 3 integrated levels. How do translation AIs work? By recognizing, pairing, and combining learned patterns. So what is missing? That's summary of what we've seen already. What's missing based on the error analysis? Either to ameliorate or to remedy those problems we've seen, particularly the pragmatics problems, the ambiguities, and so on. They might reply, the promoters might reply, well, all it needs is to be faster and vaster in the data set terms, with some add-ons like fine-tuning. But that will have to be demonstrated for us to believe it. Or there's going to be some unknown emergent singularity. AI is going to evolve human-like skills. What are these fine-tuning tweaks that industry is proposing? For noise, we see, and these are just extracted from a number of papers I've found, found on the net and so on in research, where the research team at the end of the paper says, well, okay, this is not working too well, but we can do this. So, for example, they'll say, add a disfluency cleanser. Okay, but how, they don't explain how they will separate meaningful noises, communicative sounds and words and ums and ers and rhythm and pausing and so on, and patterns, repetition, from non-meaningful noise. Others say they will use sentiment analysis, but they don't explain how that will work. I looked it up. It doesn't explain, except that basically it's also detecting emotion from certain words. If the person says this is incredible and amazing, of course, fine. The third proposal would be make the output voice more melodious. As I said, I invite you to test the output from, for example, that short business speech or anything else, any colloquial speech translated and then spoken back. Simulate the original speaker's voice. That's one bright idea that's come up. Imitate the prosody. Problem is, prosody is used differently in the other language. So it seems that tends to miss the point. And finally, some just say, let's add a pragmatic capability. Okay, I'm pressing ahead. So what does it take to add a pragmatic capability? Easier said than done. To do that, an AI would need to be able to read the clues in discourse. That's the things that show you how to infer, how to take the thing, the little markers, point you to certain context, which you would have to retrieve, process the context with the surface content. Very hard to see how a machine can do that. And then for translation, compose output in the new language that gives hearers access to the same explicit and implicit range as available to the SD or SL audience. Looks like a stretch. So since this looks like a stretch, many people are saying, well, let's take it one thing at a time. You mustn't be a Luddite or a neo-Luddite. For those who don't know what that is, it was a 19th century gang of an early industrial revolution in Britain who wanted to smash all the machines because they were. So neo-Luddite is someone who's against technology, but I'm not really, because I use machine translation myself. For example, the Ukraine war, or these Russian statements or Ukrainian statements on Twitter, you know, very useful, DeepL. I use it all the time. But there's a difference between for example, we're going to see here pre-editing input for other human interpreters and for an AI. So let's look at this now, since this has been the subject of some discussion. An intermediate step, if the AI is not ready to replace us completely, human-machine collaboration. The promise of many types of technology is always the same: relieve us from drudgery. Computers will do the boring stuff, as the AIC seminar in Dublin was told a couple of years ago. Claudio Fantinwali, speaking here also at the Center of Translation a year ago, sets out a trajectory of technical development in history. First, humans had no technology, so long ago, nobody can imagine that. And then there's a phase of augmentation of humans with tech tools, with technology. Homo faber, the tool maker, develops all kinds of tools. And today, these include computer-assisted translation, interpretation, for preparation, in interpreting for online terminology lookup, and it's very useful. We've all used that. Augmentation 2, however, is a switch. The machine is in the driving seat. It's technology in the driving seat supported by humans. And how could that work? Well, one idea is pre-editing or post-editing, as people know who've done a machine-assisted translation. And in interpreting, the idea is re-speaking, which would mean that people who, when there are speeches, for example, the European Parliament, that are in very rough English, for example, because they're non-native English, then they're re-spoken by a professional re-speaker, cleansed of disfluencies and made much clearer and so on. And then a machine translates them into all the other languages. Of course, at a considerable saving to the personnel budget. Now, is that viable? I tried to reach some judgment on that. Some people are enthusiastic, but I have problems with it. The first division of labor, the so-called isolating the boring stuff. I can't see how this is going to work. I can't think of a speech that has some parts that could be done by a machine translation program as I've analyzed it, and other parts that couldn't be. I don't know of any speech that is purely made up of one or the other. So I don't see how to sort out so-called boring stuff, routine stuff, from interesting bits of the discourse. Would it be by speech? I don't think so. Or by meeting or by session. How could you classify different kinds of discourse as persuasive or or informative? And my second big problem with it is the cost benefit. This is, should we? Are human AI partnerships as we envisage them efficient? Are they worthwhile? Would they be effective? So try and look at that a bit more closely. I should say that I have done this re-speaking on more than one occasion, once for 6 other booths from a Japanese speaker who was hard to understand. But re-speaking for humans is not the same as for an AI. Re-speakers for your interpreters in other booths, you're supposed to clean it of noise and accent mainly, misused words, perhaps mispronunciations. You don't repeat the throat clearing and so on, unnecessary repetitions, and any noises that don't seem to be communicative or intentional. But if a re-speaker is re-speaking for a machine interpreting algorithm on the basis of the performance of what a machine interpreting machine algorithm can recognize and can deal with, as we have seen it, might be tempted to cleanse it a lot more, to pre-chew it, pre-masticate it, as you would give a baby pre-masticated food, features which might cause problems, such as empty words, Schütze, which we know that doesn't mean anything now, because that's pragmatics has shown that these words are not empty, they're instruction. Non-standard word order that actually conveys a meaning. Creative metaphors, things that are rare, colloquial, foreign or new words, slang, potential ambiguities, all these things might be flattened out by a re-speaker, might be tempted or instructed to do it. Irony, sarcasm. So if all those things seem to pose a problem, this would then probably be necessary for all speeches, reducing them to pretty colorless, flat recitals of information just to give the AI a chance. Karibsky et al. Seems to be, the main reference Claudio Fantinoli referred to, where they tried to assess, compare re-speaking with AI to all human interpreting. And it's a very conscientious effort, but the results confirm the bias, which is unavoidable towards text-based and informative features in the evaluation. The same error categories pop up in this paper, in this study, as have been discussed earlier in this talk at the linguistic level and at the upper strategic levels. First of all, the oral features of language, which are very important for judging the readiness of a program, could not be addressed because the AI output was text. So Karibsky could not cover voice output quality at all and had to focus on content. In other words, the informative factual dimension, biasing to the evaluation towards that. For what could be measured in this study, they found more style errors, unsurprisingly, more errors of correctness, though, also, and fewer effective editions. This is when interpreters edit, but that's optimization. And fewer omissions, which is also optimization, but they haven't been able, but they're well aware, of course, the research team, that interpreters use omissions strategically. So you have to, you can't automatically judge that these are errors, far from it. So in other words, this really seems to confirm what we've seen so far. And it basically, re-speaking, it looks as if it solves all these speech recognition problems. But if re-speaking includes all the tasks of an interpreter, making all the choices, simplification, summarization, concision, etc., you might as well do interpreting. Re-speaking for artificial intelligence seems to me to just kick the can down the road, postponing, pushing the problem beyond speech recognition onto the module, onto the translation module and the thing. It might be just as tiring for the re-speaker as direct interpreting. In fact, there is research, not mentioned here, Galay and others, shows that even in post-editing in machine translation can be just as tiring as doing the translation directly. There's a risk that this respeaking would over-cleanse the speech, taking away useful pragmatic features, and that therefore it would be more tiring to follow for TL audiences, which would receive it in the AI synthetic voice and wouldn't have the same helpful pragmatics. In short, respeaking seems to call for more effort for fewer cognitive effects, whichever way you look at it. So look, let's try and summarize and answer these questions, if I have time. Do I have time? It's 11:28. I'm sorry, I must try and leave time for questions. So, okay, additional obstacles. Lexical coverage can be fixed with a data set. Recognizing oral language specifically, still very weak on that. Voice output, still in its infancy. So these are still three big problems to can we use MI. Secondly, there's a so-called, it's a sort of clash of values. The systems we're seeing are strongly biased towards intelligibility and convenience, and marketable values like flattery we've seen in the case of generative AIs, comfort, convenience, intelligibility, instead of the ethical values of authenticity and fidelity. Should we then press ahead nevertheless? Of course, the motivating forces, we know what they are: profit, motive. There's nothing we can do about that. And there's also this shift of faith, this techno-faith. It seems somehow we're not just boys who like taking apart the radio and enjoying tech and imitating, trying to make a machine that'll do what the people can do. We've actually got to the point where we seem to be putting so much money on technology. It's almost as if we were tiring of being imperfect humans, and somehow we believe that technology must be better than us. There's a little whiff of that sometimes in the commentary. We shouldn't have such a big opinion of ourselves. We're not so great, you know. The machine is amazing what it can do, all kinds of things and so on. But it's really not, to me, the point of quantitative linear comparisons. It's really that we're quite different, and each should be able to do what they do best. After all the risks with pressing ahead, regardless, dilution of intellectual exchanges, misinformation we've seen in ChatGPT, and if this is deployed nevertheless, people will be disappointed with MI, and they may fall back on the lingua franca on English and just forget that. The idea that machines can do the boring stuff does not seem very viable, because it seems rather hard to separate it. It's like a recycling problem, but the sorting seems to be a problem. Respeaking seems to just displace the problem to me. It's not much point pre-masticating the input if the other modules can't process it. Augmentation one, helped by technology to look up online, on the contrary, on the other hand, is very valuable, while respeaking in comparison looks clunky, costly, and uncomfortable. So why don't we rethink which tasks are best done by each, instead of comparing and trying absolutely to replace one by the other? Joseph Weizenbaum said, one of the early skeptics who did a chatbot that worked in 1966, he said, yeah, but we should only use computers for certain things. So we've had that slide, and that one, I think most input is still too hard for AI. Users will prefer human voices probably, and will not really want to talk in a way that serves the weaknesses of a machine. Worst comes to worst, if it's deployed nevertheless, they may say, oh, I can read this in text. They don't have to go to a conference, especially with a robot voice. So in a liberal market economy, intercultural communicators can vote with their feet. They may reject unsatisfactory interpreting. And of course, that may lead to a loss of monolingualism and of cultural diversity. If we're pressured to accept it anyway, well, this is basically things I've said already, and it may be that our dumbing down, a voluntary dumbing down of discourse to accommodate artificial intelligence, language technology, replacing irony, ambiguity, ellipsis, and so on with explicit, simplistic, and inoffensive, harmless material. It may be that this voluntary dumbing down so that we could adapt to the robot side of our cyborg plan. I mean, it's part of a transhumanist approach. It may be this dumbing down has already begun. A historical study would be interesting. That's one of the many things that I hope younger, more motivated and equipped researchers with more time and patience than me will look into. As Joseph Weizenbaum said, we cannot humanize AI because AI is irreducibly non-human. Living well with computers would mean putting them in their proper place. As Ye-Jin Choi said, the one who talking about dark energy, for the foreseeable future, we should rely on AI only while using a little common sense of our own. And I'll just leave those conclusions up there. Thank you very much for your attention. I'm sorry I hope I've left half an hour for Q&A, at least half an hour.
Yes, at least half an hour, 25 minutes, actually.
Okay.
Well, thank you so much, Professor Robin Setton, for this extremely rich and comprehensive account of interpreting in the age of AI, and for providing us with such a clear diagnosis of what machine interpreting can do or cannot do, and with so many fascinating and fun examples. And we do have 25 minutes here for your questions. We'd love to see your face, hear your voice, so you can turn on your camera and your mic.
Is my camera not on?
I think your camera is on. Yes.
Oh, okay.
Yeah, we were actually we were able to see you in one of the little boxes, next to your slide. Alternatively, if you want to type in your question in the chat box, you can certainly do that. Okay, let's see whether.
Okay, so I have a little chat box I can open up here.
Yes.
I've got some coming in. Maybe that's the best thing to do. Some people saying they were amused and where they come from and so on. Hello to everybody. There's no actual questions I've found. 战争是一笔肮脏的交易. Okay, yeah, maybe that's better. Anthony Pym.
Yes, that's what I'm saying now.
Two questions missing from the presentation. He says, how much of the world can afford to pay for conference interpreters? Sounds like an economist question. In a different system, I guess, things would look very different. Yeah. Two, doesn't interactive MT offer a range of solutions that the user can choose from, augmenting human capacities rather than replacing them? That's interesting. I'm sure there are things, for example, slow down button and stuff. I don't know what Anthony's thinking of, but if he has examples, I won't type this in because it'll take me too long. While he's digesting my, let's see.
Can I ask the questions?
Hello? Is that, yeah. Anthony.
Hi, everybody. The first question is important. I think unwittingly you are being elitist and essentialist. You're speaking on behalf of the rich world that can pay for superb conference interpreters, but most of the world can't. And so the AI is offering cheap, immediate solutions for the transfer of knowledge to a wider world that really needs it. That's the first question.
No, I can't. Yeah, I can't really buy that as because that's rather like saying we can give not so good products to the third world. And there's no, I mean, I haven't gone into the economics, but I don't see why good conference interpreting should be reserved for the rich world. But I don't have a choice.
Very expensive.
No, I'm saying that Yeah, but I mean, it could be in a different system. It could be subsidized and funded. In the UN, for example, it's a question of enfranchisement. I mean, that's not really my issue. My issue is to find out if it's good enough for communication. If it's not good enough, then we shouldn't even give it away. I mean, is it good enough? I mean, that's a basically approach which says if it's good enough, then we should spread it around. Although it's a second-rate product, we should give it to the poor. Well, I don't think so. I think we should either, subsidize it or have it consecutive, or not have a conference interpreter. I didn't mention conference or simultaneous interpreting. But that problem, I think, is independent of this problem of whether these algorithms are going to do a decent enough job, which is what I was trying to focus on. But anyway, it's probably for a longer discussion.
Okay. The second question, I'm thinking of DeepL, where you don't like that solution, you click on that and you can choose from the other solutions. It's very interactive, and the real aid
that's
thinking about language. And surely
machine
that
translation.
So interpreters can have a feed coming in and work from various feeds as a source of inspiration and suggestions.
How would it work in interpreting? How would you work from several feeds? It's hard enough trying to do one speaker. You could have screens, of course.
Written feeds, written MT coming in. And if you're blocked,
no, I know. Well, that's part of what I salute and welcome, which is all these aids. This is humans augmentation 1, according to Claudio. Is humans aid helps. It's not the other way around. The other way around is what causes a problem for me. I can't see it's that where the AI is in the driving seat, and you're supposed to feed it so that it can interpret into other languages. Anyway,
but all your examples have just given one solution from the machine, from the system, whereas interactive machine translation offers many.
No, there was one where. There was one where I showed that DeepL does give several options. They often give several options. But anyway, I couldn't give examples of everything. Thanks for your question anyway.
Thank you very much. Thanks for the talk. Been great.
Ebru Dirika has a question here. She talks about user expectations, which are poorly understood. But definitions of fidelity and intelligibility can change from user to user, quite. Interpreters try to watch for such changes by monitoring how the communication unfolds. Yeah, that's right. That's another aspect. Thank you, Ebru. I see Wang Jimbo. Okay. Can't wait for augmented will always be. Do you think augmented human interpreters will always be human interpreter plus CAI tool will always be better? This is similar to Anthony Pym's thing. Will always be better than MI in the long term. Well, I can't see. I see a hell of a lot of obstacles ahead of full MI. I can't really conceive of it, and I find it difficult. This is regardless of whether it'll take my job, because I'll be long since gone. I hope you believe me. There's not a conflict of interest. Okay, another question. Thanks for quoting. This must be Sabina Brown. Karibsky was a pilot study. Such a lot to discuss. Sorry, I have to leave. Well, that's a rule. Yeah, no problem. Yasman Sidi. What does he say? The private. I see my colleagues getting fewer and fewer assignments, worse interpreting rates for humanitarian meetings. The private sector will probably barely look for interpreters anymore. It'll be institutionalized. There'll be less demand of interpreters. Should we consider conversion to other jobs? I can't address too much in that. That's economics, society, politics, everything. I can't. But it's a very good question. Li Wenjie, connectionist language learning theories argue that the success of large language models support the view that language is learned via repetition, probability patterns that people learn to become sensitive to. This idea seems to account for the biases of machines, as they are part of the inadequacy of existing stochastic patterns. How relevance theory can against such a view? I don't understand that question. How? Well, that's a bit of a complicated one. Maybe he can send that to me, and because I don't know if I can deal with that online. Okay, I think those are the ones on the chat. Anyone else? Margaret Ding raised hand.
Okay, please, Margaret.
Thank you, Professor Liu. Thank you, Professor Robin Setton. I have two questions. The first one is when we talk about should we or will we questions, should we just take different settings into consideration? As we know that there are many differences between human interpreters and AI interpreting in different something that we consider that there is some difference in these two, but in fact that we have used AI interpreting in a lot of settings, especially the non-formal settings. Just to take the recent Asian Games in Hangzhou and the Beijing Winter Olympic Games, for example, the athletes tend to use the translation machine to talk to the volunteers and our staff. For the interpreting agencies, they tend to save their money. So it is good when it comes to saving money for them to use AI interpreting. So when we talk about these questions, even we don't want to use AI interpreting when it comes to the fidelity, the emotion, but the fact is, in a lot of settings, we use AI interpreting.
I'm not quite sure what the question was. It ends on a statement, but it seemed to speak to the similar issue that Anthony Pym raised about when you can't afford it or when it's difficult, then AI is very helpful. I mean, this is absolutely the case for an enormous number of things, and I may not have said enough that I may have not have said insistently enough that speech to speech, well, not so much speech to speech, but even speech to speech has been very, very useful for a limited range of applications like tourist exchange of information, stuff like this. Fantastic. I travel around, the taxi driver shows me his mobile phone and so on. But the more complex an application you go to, the harder it is to actually get even usable quality. You get to what is usually done by simultaneous interpreting. It's very difficult, according to what I've seen, to find anything that can reach a usable quality for anybody. It's not a question of money, and it's doing a disservice to people to pretend that they're giving them for a cheap price an automatic thing which is much cheaper than a human interpreter, but actually it will cause damage. It's not worth using. It'll distort communication. It'll give misinformation. It will lie. It will flatter. It will be censored. So I really think it's not one can't just say it's a fact you've got to use it because a lot of people can't afford simultaneous interpreters. So anyway,
yeah, I agree with you that in some conference we use simultaneous interpreters and consecutive interpreters to do human interpreting, but for most of the non-formal settings we use AI, the interpreting machine. When it comes to the non-formal settings, and our athletes and the staff, I mean thousands of people used AI interpreting.
You're talking about simultaneous?
No, not simultaneous, non-formal situation.
Okay. No, I think one has to distinguish applications very carefully. I think you're probably right, but I think one has to describe the different applications very carefully to see. As I say, there are applications where sentence by sentence tourism or something like this, what you may call non-formal, this is, has to be depending on how you define these things. Yeah, definitely. There's a whole range of it work. Okay. Thanks for your question. Next is Setton. I'm sorry, but we don't have all that much time for 103 questions per each person. Sorry, but I'm not the moderator.
Yeah, probably Margaret, you can come back later. So we do have another question in the chat box. Robin, are you seeing this one from Yin Hui Li? Yin Hui Li, yeah.
I can see Setton raised hand, and I can't see the chat box anymore. Wait a minute, where? Our chat, yeah, here we are. Sorry, yeah, chat box. Oh yeah, Li Yinghui, right? Li, thank you. Okay. A speech recognition assisted consecutive interpreting, where the speech recognition converts the source language audio into text in real time without translation. So that's like for automatic transcription or subtitling, while also recording problem triggers. Oh, Daniel Gilles is immersive as a surfaced here, such as numbers and proper names. So what's this supposed to do? Is it supposed to warn you of problem triggers? Warn who of problem triggers? If they're an interpreter, they know about those problem triggers. Is it supposed to warn the AI? I don't understand that question. I'm sorry. Do you understand that question?
Yes,
Yvonne?
yes, I think, Robin, the question's about, what do you think of AI-assisted consecutive interpreting, particularly, with this assistance by automatic speech recognition to provide, problem triggers such as numbers and proper names. So basically, a lot of times interpreters think that these are the difficult that make their task difficult. That with assistance in providing the numbers, even the translation of proper names, what do you think of AI-assisted consecutive interpretation?
Well, you mean, for example, I'm doing consecutive and I have a screen in front of me, and things like proper names that might cause problems will flash up the proper translations will flash up. Yeah, I think that's great. Yeah, I would often like to have that. That's often what a boothmate used to do. Yeah, that's the kind of augmentation one which I approve of. It's augmentation two, which I think I can't conceive of very well, where the human is serving the AI. It's the other way around. Seems to work okay. Okay. Somebody. Okay. Any more? Chen Tong raised hand. View.
Yes, Professor Setton, can you hear me well?
I can hear you, but I don't seem to be able to. Oh, there you are. Yeah. Yeah.
Yes. So basically, my question is related to what other people previously asked. And I'm a professional translator and interpreter. And in the industry, I noticed that agencies or the users tend to push us to use AI-assisted tools more and more. For example, they would use, let's say, a computer-assisted tool software to display translation from automatic recognized text on the screen while we do simultaneous interpreting. And we were asked to do kind of side translation as a form of simultaneous interpreting. And in another case, my colleague arrived at the venue, and then the organizer just decided they want to use AI tools. So my colleague was just asked to stay in the booth and just read out what the AI tool kind of typed out. My question is, how do you think we should, as professional interpreters, we should actually let the agencies or our users know that we are actually better? How do we position ourselves? And I totally agree that I think human interpreters contribute significantly to the interaction that AI cannot actually compete. But what's your opinion, please?
Well, from listening to you, I get the impression I'm hearing an example of it's more to do with marketing than interpreting. I would think often people in all fields, if they got some technology, people love technology, so they will try to be able to say in the brochure, we use this technology. They might well add it on, even though it doesn't do anything. In fact, it may be even it's a gimmick. The way you described the first example you gave, you're reading this out. The AI is doing it. One of you is not necessary. So you or the AI are not necessary. I would say. So that's and what do you do with these agencies? Well, that's a whole different thing. That's a problem of your power position compared to your employer. I mean, that's more a kind of trade union, or I would say what power do you have to tell them to do this or not do this? So that's a different matter. But it doesn't seem from what you say that this kind of add-on feature was very useful. Asking you to read something that's already been probably less well translated by the AI. I mean, you may have to humor them just to pay your rent, is the only answer I can think of. We've all had to do that in our lives sometime.
Yeah,
okay, sorry.
Yeah, thank you very much.
Okay, I have a meeting chat here. Should I take that one, Minhua?
Yes, please.
Stephen Chang, is that the one?
I think
yeah, that was the next one. Yeah.
Okay.
That was the one after the one about assisted consent, AI assisted consent. Stephen Chang says decision-making processes can be complex, but AIMT seems to overly simplify the process of decision-making in translation. Also, machines cannot understand the meaning of words. We know that. Okay, the creating illusion. Okay, machines cannot. Okay. I'm curious to know. You mentioned MI being capable of creating meta representation. I didn't actually. I said it might represent, but I can't imagine how it can meta represent. So I'm skeptical. To me, mental representation is a complex human mental capability that enables us to imagine intangible things or even the esoteric concept of morality or empathy. I believe that machines, if they had any representation at all, would have a very different one from these. What do you think? I absolutely agree with you 100%. English department, Suzhou. Yeah, absolutely. No, I don't think they can have the same kind of representations. Okay, Wing Chi Ho from response to Margaret Ding, she says, Margaret Ding's question sounds more like a problem of general bad use of the language in modern China, oversimplifying and westernized Chinese. Okay, that's another whole debate. That's another whole debate. Okay. So that's the end of the chats I can find. Anyone else?
Robin, there's actually an earlier question from Margaret Ding. If you can scroll up.
Another one from Margaret Ding. Okay.
Yes. Can AI render very typical Chinese? Are you seeing that one?
No, but you can read it to me.
Okay. It's a long one. Can AI render very typical Chinese expressions, which can
like
even
like
she's giving some examples here.
Yeah,
can you see it now? Okay.
Yeah, so it can even be hard for human interpreters to understand and interpret as AI may evolve in the future. Well, I would say that it's fairly obvious from my presentation that I think that AI for the foreseeable future will be a long way behind what humans can do. And so it's a very strange question. Why should AI be able to render very typical Chinese expressions, which can even be hard for human interpreters to understand and interpret? I mean, the other day there was a post from a certain James Becker on Twitter. This man, he is one of the team at OpenAI who do ChatGPT. And he posted the fact that he said, I'm really finding out after comparing, and he's been training their models, ChatGPT, that all these models are actually they're actually their data sets. There's all these hyperparameters and so on. It makes no difference whatsoever. I've found out that when you're talking about Bard or Llama or whatever, what you're referring to is not some particular ability. It just be whatever data set it is. There's no difference between them. They are their data sets. They identify completely with their data sets. So that would be the answer to this. Can, if you put all the Chungyus that have ever been used in the last 500 years and in all the contexts that you can find into the data set and give it and train the AI on it, possibly, but I don't know about translation because that's a very different thing. Proverbs are notoriously flexible. Proverbs can be used in all kinds of I mean, they don't mean one thing. People use them, misuse them, and use them very loosely and flexibly because people love proverbs. Okay, she gives an example. A colleague of mine did this speech yesterday. I'm a bit slow reading Chinese now, but we will take the lead in education by launching programs with the university's characteristics and uphold the principles of openness, blah, blah, blah. My friend told me it was very confusing for him to understand 高位什么？
高位嫁接。
高位嫁接 drafting at high, yeah, that's right. So, no, I mean, there's plenty of examples of nonsense that comes out. As I've shown, this was an example, presumably, of nonsense that came out. And in a situation, human interpreters can sometimes perform equally unsatisfactorily as AI. Well, I don't think there are certain kinds of mistake that it's true that when we were training, we were training interpreters together, meanwhile, for a long time, and then we both went on training interpreters elsewhere. And we did occasionally see students, maybe out of confusion about the translation process, actually saying nonsense and knowing when you told it to them, back to them, that it was nonsense. Yeah, because they're sort of misled into this by some idea of translation process, and the words just came out automatically as equivalents. So that's true, yes, humans may say nonsense, knowing it's nonsense. The result's the same for the era, only the AI doesn't know it's nonsense. So I don't really see, I mean, it can happen in both cases. But then she says, in that situation, human interpreters can sometimes perform as equally unsatisfactory as AI. Can sometimes, sure, but I mean, that's just like, such situation is very often arising in Chinese speech when it comes to conference interpreting. Does she mean nonsense interpreting into Chinese or from Chinese? If AI can do it well, I think it will give us greater threats. I don't know what that means. Does that refer to threat of jobs, or I can't fully understand the question, but one can always send me the questions. Okay, 3 new messages below. Shall I take those?
There's one.
Yeah, the person
there's one from Yinghui, Li Yinghui. I think it is a follow-up question to her previous question.
Oh, there's one before that by Damien Fan.
Okay, so that's further down. Do you want to take Yinghui?
That's the next one I could find up. Huh?
Okay, go ahead. Go ahead to answer the question you're seeing now.
Public audience education. MI might not be accepted as widely and quickly as tech providers claim. That's what I said. I don't think it will be because it's not good enough. Should interpreters take up the challenge to do that? To what? Sell MI? No. As a background, some RSI platform executives have experimented with machine interpreters, claim they're quite effective for technical meetings because the audience is more knowledgeable than interpreters. And these medical doctors or engineers only need the content words to fill in the gap on their own. Yeah, that was often the case with human interpreters. And yeah, I can see that might, if they just need those, then they can fill the gap. It's true. It's, I mean, I find automatic translation useful when I've got a text that I have no idea about, and it at least tells me what it's about. Because if it tells me what it's about and I'm really, really interested, I can go and try and find a better translation, but I can also dismiss it. Or if I want to know what it's about, only what it's about, that might be useful to me too. Irina Zubanova, would you agree if speakers are required to pre-edit their speech for the convenience of MT, that would lead to a dumbing down in communication? Yeah, that's what I said clearly. Zainab Kirzal, to everyone, I recently interpreted a Zoom meeting where the speaker flatly read out a text she had prepared and read and fed to Zoom for speech-to-text translation and subtitling into Japanese. The speech had not been dumbed down, but was written to be read and translated as opposed to being oralized and interpreted. Result, both the listeners of the original language and interpreters struggled to follow and engage with the material. Oh, I thought she was going to say, and so it worked a little bit better because it was written to be read and it was read, which is quite different from what we complain about as interpreters, when things are written to be read out. They're written, but they're written speech, and then when they're read out, it doesn't work very well. So we don't like people reading stuff out. But here, the speech was not dumbed down, but was written to be read as opposed to being oralized and interpreted. And everyone struggled. Well, simply because if you're at a live thing, you should oralize. That's more human. If you read stuff out, you get more dense stuff. But if nobody can follow, the density doesn't get across. So you might as well send it by text. Yeah, I hope this does not become a trend. Alas, it became a trend 80 years ago with the beginning of conference interpreting, people reading stuff out. Okay, thank you. Those are the ones I can see on the chat. Have I missed any?
There's an earlier one from Li Yinghui, and there was also a response to Margaret Ding's question. I think Margaret Ding will be able to see that herself. The question, should I read it out to you, Robin, from Li Yinghui?
Li Yinghui.
Yeah, it's several
About whisper.
several questions about
Assisted consecutive. We had that one.
No, there's a later one. With the recent advancements in ASR technology, such as improved recognition accuracy, even in the presence of background noise and variations in tones, for example, Whisper by OpenAI, what are your thoughts on the future use of ASR assisted consecutive interpreting, where ASR converts the source language audio signal to text in real time without translation, while also recording problem trigger? Oh, I think, yes, sorry. I mean, you did answer that one. Sorry about that.
Yeah, I think so.
Yes. I just didn't read the first part of the question. I think this is it. And quite a few, quite a few participants were asking about the recordings. Yes, most of our translation seminars are recorded, and they're available on the website of the Center for Translation. So you can, we also have our YouTube channel, so you can also see the recordings there. Okay. So right now is our 7:05 in the evening. It's Professor Setton's 12:05.
Yeah.
Thank you
Thanks
so
very
much.
much.
Thank you so much, Robin. This is fascinating. And
Well,
you're seeing a lot of reactions in the chat box. We'll stay a little longer so that if you have a chance, if you want to read all the reactions. And audience, thank you so much for attending today's seminar. And I look forward to seeing you again in the future Center for Translation event. Thank you very much. And thank you again, Robin.
Thank you. I'll turn off my video and follow the reactions.
Yes, me too.
Talk to you soon, though. Talk to you soon.
Yes, same here.
No. Bye.
Okay, goodbye, everybody.